Okay, so whilst I'm waiting for some bits to come in for the Bantam and also for the tank sealer to come in for the little Garelli mini bike that I've been working on, this came in. This is an inverter kit for the milling machine, which I actually ordered this when I received the milling machine, and it's taken quite a long time for it to come in. Apparently the inverters were unavailable, and they couldn't get any of the inverters. So I placed the order in February. It's now 2nd of May, and I received this on Friday. So yeah, it's taken a few months to come in, primarily because the vendor explained to me that he couldn't get hold of the inverters. Now, it's quite a long time to wait for some bits and pieces, but I stuck with the order and tried to be as patient as I could be, even though I'm sure the guy was sick of me emailing him to find out when things were happening. But the reason why I decided to stick with it was because, well, for the reasons why I ordered it in the first place. One, he uses the Mitsubishi inverters, which are they get a very good name. They're you know, good make, well-known make, and I've heard good things about them. Seen other people use them on other channels and get good results. And also the pendant, or the control panel. I like them. I think they're a nicely presented piece of kit. And again, I've seen other people use them and speak highly of them. Notably, John Mills on the Double Boost channel. So that's the reasons why I ordered from this firm, which is Newton Tesla, a UK firm that specialise in electric drives. So that's the reason why I ordered from them, and did my best to be patient, even though I'm quite an impatient sort of guy, to wait for it to come in, because I could have cancelled the order and gone with somebody else, but in all fairness, you know, the milling attachment on the MCO lathe has tided me over. I wasn't desperate to use the big milling machine, and in all fairness, it was better for me to wait for the kit that I wanted than to compromise and go with something else just for expedience. So anyway, I'm going to stop waffling. Let's have a look at it. So as I say, you get the CS80 Mitsubishi inverter. This is a 1.5 kilowatt, I believe, a 1.1 kilowatt rather setup. So that's the inverter. There's a little cover that goes there over the mains terminals, which I've removed just to have a look at it. You get the nice pendant with a decent length of wire on it. Tinned ends rather than terminals. We'll see how they get on. I might put terminals on those just for longevity, although I'm sure the tinned ends will do the job. It's not as though you're going to be yanking on the cable or taking them in and out. The pendants, though, as I said before, I do quite like. So you've got your start and stop, forward and reverse. The jog feature, very useful, obviously, on the jog. When you press the start, you get rotation only while you've got your finger on the button. So if you're tapping a hole or something like that, you can just pulse it in. And then the speed control with the speeds relating to the frequency printed on. And I just think it's a nice. I don't know how long this printing is going to last, but it seems pretty good quality, and it's just a nice professional looking thing. So quite happy with that. You don't get a mains lead, which is, I think, fairly common for these packages. I've got this mains lead here, which I'm not going to use this on the final assembly. It's a bit of a scabby old one, but I've put some ring terminals on the end of it just so we can give it a test and get it going. As I say, I'll use something a bit nicer when we do the final installation. They're the motor feet, which you get. You can configure the motor in various different. Oops, bring it into focus. You can configure the motor in various different ways. The feet have a number of holes drilled in them. slotted in them rather, and then the mounting holes, and you can put the feet on in, I think, 3 different positions. I think I'm going to have it with the terminal box out the side rather than at the back, because it'll give me a little bit more room at the back of the milling machine. Now, the cable that comes with the motor, it's quite a good quality feeling cable. It's not armoured, although you could put armour over it if you wanted to. It's nice and flexible. There's your 3 phases and your earth connection. And the only thing which I found to criticise, and it is a criticism, is the way the cable has been fit to the motor here. You've got a cable gland on here and the cable emerging from the cable gland, and it's just had insulating tape, and it's the yellow and it's not even black insulating tape or grey insulating tape. It is the yellow and green earth connection when you're wiring up mains in houses and you use an earth connection insulating tape, and that's been wrapped around the cable to prevent the cable from pulling through the gland, because obviously the cable is smaller than the capacity of the gland, and it's to stop it from pulling in and out of there. They've wrapped it in insulating tape, and well, it does stop it from pulling out of the gland, but it's not particularly attractive. I would have used some heat shrink, perhaps, like they've done at the other end, which is nice. Yeah, that looks professional and nice. I don't understand why they didn't just put a bit of heat shrink on there, rather than having that naff, quite frankly, bit of insulating tape sticking out, which in my opinion lets it down. It's an aesthetic thing, it's doing the job, you know, it's perfectly serviceable, but for me, you know, me being me and me being quite finicky about how I like things, I would have either used a cable that fits the gland, a gland that fits the cable, or just some nice heat shrink on there, just so that you get a decent professional looking job. But that's, as I say, that's the only criticism that I can find. Everything else is very, very nice. Happy with the quality of the equipment and the components. So yeah, stop waffling, let's get it wired up and see if it works. Right, so we're looking at the inverter itself, and the Newton Tesla supply you with these wiring instructions, which are pretty good actually, more than comprehensive enough to do the job. And also you get the Mitsubishi user guide for the inverter. Now, when you buy the package like this, it comes pre-programmed. It will do everything that you need the inverter to do to work with this pendant. So it's already been programmed. I don't have to mess about with anything like that, which I'm frankly quite pleased about, because you know, I'm an absolute novice when it comes to these things. I've never had one before, so I can imagine there'd be some head scratching if I had to program it. I would like to fit the foot switch, the kick switch, to kill the mill, the emergency stop, at some point. So I'll be getting back in touch with Newton Tesla and finding out what the best means of doing that is. But in the meantime, let's just have a look at the wiring, and we'll see how to get this thing running. So first of all, there's a little hatch or door at the top here, and you open this. If you can see that, there is a row of terminals. Well, there's a number of rows of terminals, but the one we are principally interested in is this one here, and they're just the little sort of, you push the little button in and the terminal opens up to accept the wire, and then it's just spring loaded and it grips the wire and holds it down. And then also down here there's a single crosshead screw. Take this off and you have your mains connections, so live and neutral. Your earth connection is down here. There's 2 earth connections here, one for the motor, one for your mains lead coming in. This is UK wiring, obviously. And then you've got your 3-phase connections there for your motor. And as I said previously, your motor earth goes to one of these heatsink screws. So what we'll do is we'll wire in the pendant, then we will wire in the mains connector and the motor, and see if we can't get it running. Okay, so just turning over the page to the wiring diagram for the pendant. And hopefully, I'm not going to get in your way too much, but excuse fingers, as they say. Obviously, I'm going to have to get in front of the camera a little bit while I'm putting the wires in, so it might obscure your view just a little bit. So first of all, inverter control terminal, remote station, white wire goes to PC, and that's PC there. Third from the end. I might have to take my glasses off. I've got my glasses on at the moment, and they're not good for close-up work. 10 is black, so let's find number 10, and that's up there on the top. These are nice and easy to do. As I say, for final assembly I may get some little pin connectors just to reinforce the end of the wires. That's not a criticism, that's just a preference. I think it would be absolutely fine to do it like this, as long as you put a cable restraint on. But yeah, I just like things to be a bit bulletproof, really. Number 2 is red, so that's up the top there as well. Try and get them so that they lie nice and naturally. There we go. I'm just using one of those little watchmaker screwdrivers to open up the... Oh, that didn't grab it. There we go. Yeah, just using a watchmaker screwdriver to open up the terminal ports. Hopefully not too dull for you watching this. Number 5 is green. There's number 5. And then yellow goes to STF. Is that right? Yep, yellow STF. Okay, that's that one in. STR is blue. That's right on the end there. And then RM for our final cable, which is brown. And there's RM. Let's check they're all nice and secure, which they are. So that's that phase of the wiring job done. And next we'll do the mains lead and the motor. Okay, well, I've had a little bit of a break because the battery went flat on the camera and I had to charge it up, and then we decided to have a barbecue. So yeah, we just had our first barbecue of the year and sat out in the garden and enjoyed it, and it was very, very nice. So it's now evening, and I'm back in the workshop and we're having a look at this inverter again. And it'll become obvious to you that I've done a little bit more work and I've wired up the mains. So we've got the live connection here on RL1 and the neutral on SL2. We've got the earth connection down here, and then I put the motor on. 3 phases. I just wired them 1, 2, 3 across the motor connections, and then earth the motor here. Now, with it being 3-phase, if the motor goes the wrong way, we'll just swap 2 of the connectors around and it'll go the other way. So no problems there. But it just seemed to, excuse me, you know, it just seemed fairly logical to the phase mark number 1, the phase mark number 2, and the phase mark number 3, just to do them in that order. So so that's what I've done. So we should be ready to give it a go, actually. The motor is over there. Ooh, nearly had the tripod over. The motor's over there, and I've just mounted it on 2 pieces of wood so that it's the right way up, and the fan's not obscured, it can get a draft. So hopefully we shouldn't have any issues. And you will notice, I hope, that I've done some heat shrink here where that naff old bit of insulating tape was. Oh, you're not doing a very good view there, are you? There you go. There we go. Nice bit of heat shrink. I think you'll agree, or I hope you'll agree, that it looks much better. Although you may be thinking that I'm just a bit finicky, which quite frankly I am. So okay, let's plug it in, see what happens. Right, okay, before I plug it in, I'll just point out that I've refitted the cover over the mains input and the motor phase cables, because obviously this video going on YouTube, anybody could watch it. Most of us that have workshops would know to keep our fingers out of live mains, but you know what, we all make mistakes, and I think it's the right thing to do, to just to show a bit of best practice and put the safety cover on. So that's what I've done. So we're going to go and plug it in now and see what happens. Hopefully oh, we've had a click, and we've got a readout on the display, on the frequency display, which at the moment is showing 0. So let me just put you back down again. Excuse the dodgy camera work. Come on, you're used to dodgy camera work now. There we go. You can see everything, see the motor. So I'm going to go and just have a look at the control panel. So we're at run, forward. The speed is at the lowest setting. So let's go and press the start button, see what happens. Alright, so we've got 5.08 Hertz on the display, 5.09, and that's the lowest speed, which on the Pendant it's 175 RPM. The first thing I notice is that it's going the right way. It needs to be clockwise viewed end on when it's running forward, and that's correct. So that's good news. We don't have to mess about with the phase wiring. And the bench is growling quite a bit, but I think that's just resonating through the motor. This bench is it's basically made out of the same stuff feeler gauges are made out of. It's not very rigid, so it does tend to vibrate a bit. Right, so let's put some speed on and see what happens. Right, quietens down. 750 RPM equates to 20.15 Hertz. Well, let's do a bit more. We're at 50 Hertz in the UK, so that's 50 Hertz, and we're at 1500 RPM almost, and then it will overspeed a little bit, I think. I'm given to understand anyway. So that's 59.99, 60. It's kind of fluctuating between the two, and that's full speed at 1800 RPM. And let me just show you the readout. Stand by for more expert camera work. There you go, 59.99. So it's a 10 Hertz boost from what we normally get out of our mains here in the UK. So that works, doesn't it? Okay. Let's go the other way. Well, that's success. It reverses. Well, that's nice. And then we have the jog function as well. Put it in the jog position. And I think it's pre-programmed to just give a certain amount of RPM when you are in the jog position. I don't think the speed control will do anything, but we'll double check, because I'm not 100% sure. I've never had one of these things before. So it's in the jog position. Put it back to forward. Okay, well, mess around with speed control, see if it changes anything. No, it doesn't. So it's the jog is just pre-programmed then. Make sure it goes backwards in the jog position, which it does. So there we go. VFD connected to the motor, and it all works. Does everything that that is expected of it. So that's good news. I'll switch it off at the mains. So that's good. Oh, the display stays on, so there must be a capacitor in there, I'm guessing. Perhaps some sort of a shutdown program or a shutdown procedure. I'm not entirely sure, but it's remained on anyway. Oh, it's made a clicking sound. Nope, still on. Anyway, the next thing I need to think about, we've got a bit of a full house at the moment, look. The next thing I need to think about is where am I going to put it? Now, don't be rude. There's no need for that. I mean, where on the mill am I going to put it? Obviously, the motor will go where the motor goes now, and that'll be quite a substantial difference in size. I don't think you can see that very well. The motor that's fitted to the mill at the moment is quite large. This is the same power output, but it's quite a saving in the case size. But I'm just thinking about the VFD itself and where about to mount that. I see a lot of guys have them on the wall, sort of behind the mill or to the side of the mill, fitted on the wall, sometimes on a board or in an enclosure or something like that. But I'm not entirely sure with this one what to do with it, because on this mill there is, in here, in the column, there's a little panel on the back, and inside that panel is where all the gubs that drives the single phase motor that's fitted, that's where they live. So let me just go handheld and I'll try and get you a view. All you're going to see is a panel, but we get the idea. That's if I can get around there. I've got that much stuff in here. Let's have a look. Let's have a look. Alright, so there we go, look. There's a panel with the voltage notice on it. And it's quite a large space in there. And that is where all the you can see the wires going in there, look. The wires from mains, wires up to the motor. And then there's another cable there that goes to there's an interlock switch, a micro switch, that stops you from running it with the belt guard open. A lot of people dispense with that. And then there's another wire here coming out, which comes out of that cavity, but at the front. And that's that bit dangling down there, which I've not bolted back on. That's another interlock that stops you running it with a guard open. Well, I'm not intending to put that back, I'm just going to get rid of that. And then here, rather sad looking thing, drooping down there, is the machine light, which is, it needs replacing. It's shall we say, it's seen better days. But it's a good place to put the machine light, so I think when I get a new one I'll put it on there. So yeah, I'm thinking just put the VFD inside that compartment on the back of the mill. So what do you think? Should I put it on the wall in an enclosure, or should I do what other people have done? Sorry, should I do what other people have done and put it on the wall, or should I stick with my own idea and put it in that compartment? And my thinking is, once this thing's programmed up, which it is already, and wired in, how often am I really going to need to get in there and disturb it? Probably not very often. I doubt, I can't think of any maintenance I'll need to do, as long as it stays clean in there, which it's all sealed in, so nothing should get in there. There's no reason really why I'd need to get in and maintain this thing, unless it breaks, which, if it breaks then I've got to get in there anyway. So that's what I'm thinking. Put it in there, all the wiring can go into one central place, the mains cable can go in there, the type of machine lamp that I'll buy will be the one with the transformer contained inside it, and the mains lead coming out of it, so that can go, that can feed off the mains that's in there as well. So yeah, that's what I'm thinking. Let me know what you think, if it's a good idea or a bad idea, and why. And I'll listen, because obviously some of you guys have done this before and have got these things. I haven't, so I'm always open to ideas. So let me know. So the next stage then, we need to get that motor, get the old motor off, and get the mounting plate onto the bench and fit up the new motor. So yeah, let's get in there and get that motor off. But before I do that, I think I need to make sure that I've had my Weetabix, because it's quite a substantial looking piece of kit, and yeah, I need to make sure that I've got my strength with me. So okay, that'll be the next step, taking off the old motor and seeing if we can fit the new one.